Okay, so I'm going to do it many times. So when x is equal to minus 4, y is equal to minus 32. And minus 32 is there. Okay? And then when x is equal to 3, okay, remember, we are using this function here. Okay, y equal to 2x squared. So when x is equal to minus 3, you get y equal to minus 18. And minus 18 is going to be here. Okay, and when x is equal to minus 2 squared will give you 4. 4 times 2 will give you 8. So 8 is here. And then when x is equal to minus 1 squared gives you 1. 1 times 2 gives you a 2. So we're going to have that. Then when x is 0, y is 0. Then when x is equal to 1. Now, the good thing is because remember we said the graph of a quadratic function has got an axis of symmetry. So, all these 4 points that I have on the left-hand side of the y-axis, they have a corresponding point which is in line with it on the right-hand side of the y-axis. So, I'm going to have here y equal to 1, and then I'm going to have y equal to 8 there. Okay, when I have y equal to 8 here, and then in the other point when x is 3, you are going to have 18, and then when x is 4, you are going to have, when x is 4, you are going to have 32, right? Then you use your free hand, okay, to sketch it. So, draw a line, okay, let me use green, right? Use free hand, like that. You are not supposed to use a ruler to sketch it. Okay? You are not supposed to use a ruler. You are supposed to use free hand. So I just want to encourage you to practice how to sketch the quadratic function. So this function is y equal to 2x squared. So I'm going to label it, but I can write y equal to 2x squared. Okay? That's y equal to 2x squared. Okay, so that's y equal to 2x squared. Now, let's go and sketch y equal to, the graph is gone now. Okay, that's the graph there. It's y equal to 2x squared, right? Then let's do y equal to x squared. Okay, remember I said I'm going to use to use my brain to do the calculation because the calculator is not appearing. It's supposed to appear, but it's not allowing me to actually appear, right? So when y is equal to x squared, I'm talking about that one, right? When y is equal to x squared, if I start from x equal to minus 4, right? I need to use a different color. So let me use that one. So I'm now sketching y equal to.
I can read the calculations to you from my calculator.
Sorry?
I can read the calculations to you from my calculator.
Yeah, you can, but you see, in my case, I prefer my brain to function as well. It helps me a lot.
Okay.
Right, I appreciate it though. So when x is minus 4, y is 16. So 16 is here. And then when x is minus 3, y is going to be equal to 9. 9 is there. When x is minus 2, y is going to be 4. When x is minus 1, y is 1. When x is 0, y is 0. Right? So I'm going to have when x is 1, y is 1. When x is 2, y is 4. When x is 3, y is 9. And when x is 4, y is 16. So we just join those points. Okay, remember, this is based on the domain from minus 4 to positive 4. So this graph here, it's y equal to x squared. Okay, I just want to remind you that our domain here, the domain that we are using is from minus 4 to positive 4. That's the domain we are using. Okay, the reason why I chose that domain is for our graphs because there are 3 of them. They are supposed to fit on the same system of axes. So if I choose one which is bigger, I can end up having some complications, or another domain which is smaller, I can end up having some complications. But I decided to choose this one anyway. So that's how it looks like. So we have y equal to x squared, we have y equal to 2x squared. I'm sure you can see the effect of this factor. Okay? I'm sure you can see that when the coefficient is large, the graph, it's more like the graph is compressed. Okay? When the coefficient is greater than 1, the graph is more like it is compressed. Then it also, based on the domain, it's going to be longer in terms of the vertical distance. It's going to be longer. All right, so let's sketch that one. Y equal to half x squared. Now, minus 4x squared gives me 16. Then 16 times that, I'll get a half. So a half of 16 is 8. So I'm going to have my 8 here. Okay, that's why I have my 8. Then minus 3 squared gives me 9 over 2, that's 4 and a half. Now 4 and a half is going to be somewhere there. Then minus 2 squared gives me a 4, divided by 2, I'll get a 2. So I'm going to have it there. Then minus 1 squared gives me 1, so I'm going to have a half, and a half is going to be somewhere there. Then here I'll also have 0. Then I'm going to have my half there. And then when x is 2, that's 2. Okay, and when x is 3, that's 4 and a half. And 4 and a half is there. Then when x is 4, you're going to end up having half. Half of 16, which is in this case, half of 16 is 8. So we'll have it there. Right? Then let's join now those points. Join them. Right? And then so we end up having a graph which looks like that. And then we can label it here. That's y equal to a half x squared. Okay, I'm sure you can see that the coefficient of x squared is a half, so the graph is like it's wider. Okay, so as the coefficient becomes smaller and smaller, the graph is supposed to become wider. If it becomes greater, then the graph will become a little bit narrow. Okay, so that's how the two graphs are supposed to look like. All right, any question there? Equal to minus x squared minus 4 and y equal to minus x squared plus 4. Right, now you can see that there is a minus here. Okay, in front of the x squared there's a minus, which means the graph, in terms of the shape, it has to have a maximum turning point. Okay, so let me sketch those two. All right, I'm going to start with the first one, y equal to minus x squared minus 4. So my domain again, I'm going to use a domain of minus 4 is less than x is less than 4. So if I put 4 where there is x there, okay, I'll get minus 4 squared, which is 16, okay, so I'll get minus 16 minus 4, I'll get minus 20. You can just use your calculator yourself, right? So when x is 4, y is minus 20. Then when x is minus 3, okay, I'll get minus 9 minus 4, which gives me minus 13. Okay, minus 13 is going to be here. Minus 13 is here. And then when x is minus 2, I'll get minus 8. So minus 8 is there. And then when x is minus 1, I'll get minus 5. Minus 5 is there. When x is 0, okay, take note, when x is 0, our y is going to be minus 4. Then, once I sketch the left hand, once I plot the left hand side, the right hand side will be the same in terms of alignment. So, I'm going to have a point here, and then I'm going to have another one there. Then I'll have another one here, and then I'll have the last one. The last one is going to be 4 and 20. So 4 and 20 is there. Alright? Then you use your free hand to sketch it. Okay. So it's going to look like that. So we can label it and say that y equal to minus x squared minus 4. Now I'm sure you can see that the y-intercept must be at 4, at minus 4, which is here. That's where the y-intercept is. Okay? And our graph has a maximum turning point because the coefficient of x squared is a negative. If the coefficient is negative, then the graph will have a maximum turning point. That is, it will have a sad face. Alright? And here we have our y-intercept. There is no x-intercept. Okay? The graph does not touch the x-axis. Okay? It's very possible to have a graph with no x-intercepts. It's very, very possible. Like in this case. Right? Any question for the first one? Okay? I'm sure you can see that the y-intercept is at y equal to positive 4. Okay? Which means the graph, it's more like we are saying this graph of y equal to minus x squared minus 4 has been moved by 8 units up. Okay? Or you can say you have moved the graph of y equal to minus x squared by 4 units up. Okay, so our y-intercept is now here. That's where it is. Okay, the shapes are the same. And you can also see that the two graphs, they are slightly different as well because the graph of y equal to minus x squared plus 4, it is on top of the graph of minus x squared minus 4. Their x of symmetry is the same, their range is the same, their domains, okay, so their ranges are not the same, but their domain is the same. Okay, the range is not the same, but the domains are the same. Now, if I were to ask you, okay, just as an exercise, can you write down the range of the two graphs? Okay, I just want you to write 1.1, just write it somewhere in your book. Okay, for 1.1, okay, the range, okay, then you write the answer down. Then for 1.2, you write down the range. I'll give you 1 to 2 minutes. Write down the ranges of those two graphs. Their domains are the same, but their ranges are not the same. Can you please? So your ranges are those ones. Okay? The domain is supposed to be provided, but if it's not, then you have to decide an appropriate domain to use in order for you to sketch the given quadratic function. You must also use common sense in terms of the scale and so on. All right? Is there anybody who has got a question?